Carboxylic acid, if you look there, before we go to carboxylic acids, if you look at alcohols, you remember I said here, because of that, we get hydrogen bond intermolecular forces, right? So if you look at a carboxylic acid, it looks very much the same. If you look there, this one, then you can see there, we will also find a site, a place for hydrogen bonding to occur because it looks like the alcohols, right? Now, with the alcohols, when I drew it, I drew it upside down. I'm going to do the same here. Okay, so they are drew it upside down, very lelik. Okay, but there we find a hydrogen bond and there we find a hydrogen bond can occur. Okay, so a carboxylic acid, because of that and that, we say there are two sites for hydrogen bonding to occur. Two sites for hydrogen bonding. Okay. Then, if you look at the aldehydes on the previous page, now you can say, man, that looks like the carboxylic acid, but because there's no hydrogen, the OH, the hydroxyl group, this here will only form a dipole force because there's not an OH to form that hydrogen bond. And the same thing with the ketones, that is dipole. Okay, so back to that page where we just were. If you see there, I tell you carboxylic acid has two sites. So carboxylic acid has two sites for hydrogen bonding, and an alcohol has one site, place. A site is the same thing as a place where hydrogen bonding can occur. So because carboxylic acid has two sites, it is greater than, the intermolecular forces is greater than, stronger than. Then you see here, the ketones, the aldehydes, and the esters all have dipole forces, intermolecular forces. And then lastly there, alkanes, alkenes, alkynes. Ooh, there's a typing error. Alkynes. As well as the haloalkanes. They all have London forces. Okay, so if I tell you something like, please compare methanol with methane. Methanol versus methane. You say, all right, which one will have a higher boiling point? Well, methanol belongs to the alcohol, so it is hydrogen bonding. Methane belongs to the alkane, so it is London forces. Because methanol has hydrogen bonding, it has stronger intermolecular forces. That's why it needs more energy to overcome the intermolecular forces. That's why there's a higher boiling point. Sure? What did I keep constant in this? I kept the meth constant. I can't have butanol, a long chain, compared to methane, a short chain. I must keep the length the same. So on the right hand side, I just gave you a summary of how to answer this. I said the first point, you said the polarity of the functional group. What I just mean there is you're going to say hydrogen bonding or London forces. Okay, whatever. They say it has strong intermolecular forces, more energy is needed to overcome the intermolecular forces, higher melting and boiling point. Okay, please don't use arrows in the exam. It's just a summary for you how you answer this again. The next one is the number of functional groups. Okay, let's say we compare methanol with this one. Okay, so we compare that one with that one. Methanol with propan 1,2,3 triol. As you can see, there's 3 ols. Which one will have a stronger intermolecular force? The triol. Why? Because there's 3 places where hydrogen bonding can occur, and this one has 1 place where hydrogen bonding can occur. So this one has a higher number of functional groups, stronger intermolecular forces, more energy is needed to overcome the intermolecular forces, higher melting and boiling point. Okay? What did I keep constant here? The type of intermolecular force. I didn't compare a London force with a hydrogen bonding. Here I keep constant hydrogen bonding, hydrogen bonding. Okay. Right, next one is the chain length. Now this is one that they actually like to ask a lot. Chain length, for instance, is if you compare, let's say, ethane versus pentane. Okay, F has 2 carbons, Pent has 5 carbons. Can you see, because the one is longer, that there will be more places where hydrogen bond, where London forces can occur, and this one has 2 sides, or 2 sides where London forces can occur. So because it is longer, it has stronger intermolecular forces, more energy is needed to overcome intermolecular forces. Next, sharp. What did I keep constant here? The type of intermolecular forces. London and London. Alkane and alkane. I didn't compare a carboxylic acid with an alkane. Okay. Sharp. And then the last one there is the branched chains. So if you compare butane versus two methyl propane. Because this one is more branched, okay, the molecules struggle to make a connection. Okay, if you look here, this is a long chain, so another one can easily come in here and form an intermolecular force. Whereas if you have another one that looks like this, it struggles to, or it will turn upside down when there's only 3 places where it can bond, or it will try to get in here and will not make a nice force or something like that. So if something is branched, it has weaker intermolecular forces because there's less chance of forces forming. Okay, so between these two, butane will have a higher boiling point because it is a straight chain alkane and this is a branched alkane. You with me? What do I keep constant here? 2 things. Alkane, alkane. 4 hydrogens, 4 carbons, 4 carbons. Alright, so on the right hand side I did explain it a bit. I want to quickly look at a question. I think it's maybe the last page. Almost, yes, last page. They say they consider the boiling points of the following alkanes. Okay, now sometimes with a question like this, they might give you a graph. So if you look at the past papers, there are some graphs. Here I got a table. And like with the previous question we did, you're going to immediately write down 2 things. You're going to write down the molecular formula and to which homologous series it belongs to. Can you see it says here alkanes? Ane. So they here already gave you, they all belong to the alkanes. But it's not always that way. You have to check to which homologous series they belong to. Then, you know the alkane's general formula is CnH2n plus 2. How do you know that? You studied it. Yes. They are all part of the alkanes, so they all have the same general formula. For tomorrow, I think that 3 will be fine. I'm going to say skip that question. All right. The propanes, pro has 3 carbons, so C3H8. Methyl propane, 4 carbons, C4H10. Butane, but is 4, C4H10. Pentane, pent is? Okay, right. So let's just check here. We can see here we have 2 isomers. They have the same molecular formula, but they are chain isomers because here the main chain is 3, here the main chain is 4. So it's chain isomers. Right, then we can see if I compare the straight chains, propane, butane, pentane, then I can see the boiling point increase as I make it longer and longer. Okay? What they give me on the right hand side is the molar mass. You can see as the molar mass increase, the boiling point increase. What you can see is the molar mass of these two are the same. Why? Because they are isomers. But we can see their boiling points differ. We see there that the one with the side chain has a lower boiling point. Why? Because it has weaker intermolecular forces. Do you see that? Sure. Okay. Now they ask, explain why the boiling point of pentane is higher than that of butane. Refer to structure, strength, and energy. In the exam, they're not going to say refer to blah, blah, blah. You must know that. Okay, so let's quickly just make a summary for ourselves, and you have to write really small. There's always 4 bullet points that you must tick. The first one that you must tick there is you say, what is the obvious difference? You check. What am I comparing? Pentane with butane, so it's the length. Am I comparing pentanol with pentane? Then it's the type of intermolecular force. The second thing is you look at the strength of the intermolecular force. You say, this one is stronger than this one. Then the third bullet point is that magic one that you always say, is the one that is with the energy. Thus, more energy is needed to overcome intermolecular forces between the particles. And the last one, you refer back to the boiling point, or the vapor pressure, or the melting point, or whatever the question was. Okay, right. I'm just going to show you, this is how I'm going to divide my page up. There, and there for A, B, C, and D. Alright, so they ask you, explain why the boiling point of pentane is higher than that of butane. Okay, so the first thing that you must do is refer to the obvious difference. What's the obvious difference between pentane and butane? The one is 4 and the other one is 5 carbons. So the one is longer than the other one. Or if you look there, butane and pentane, the one's mass is greater than the other. So because they give you the mass, I'm going to refer to the mass. Okay, because that's why they give it to you. They want you to refer back to that. So I'm going to say the first one, pentane has a greater mass than butane. All right, there's my obvious difference. Then the second one, I must refer to the strength of the intermolecular forces. Which one will have a bigger or stronger intermolecular force? Pentane. So, thus pentane will have stronger intermolecular forces than butane. Okay, now you don't have to mention this, but it will be good. We both know there are ane and an ane, alkane and alkane. What intermolecular forces do we find with the alkanes? London forces. So you can say even though, how do you spell though? Like that? Even though both have London intermolecular forces. Then the golden sentence, thus or therefore more energy needed to overcome intermolecular forces between pentane molecules than butane. Therefore, pentane has higher boiling point. Yeah. So you don't actually have to give the last bullet point. Okay. Just a few things. Where will you lose your mistakes? Lose your mistakes. Lose your marks. If you say, therefore more energy needed to break pentane. Break pentane. Wrong. If you say, therefore more energy needed to overcome intermolecular forces between pentane. Wrong. You must say between pentane molecules. Because if you leave the word molecules out, they think you want to break pentane apart. But that's not what you want to do. You want to split a pentane from another pentane. You want to split them apart. Okay, so you must put in the word molecules. If you just say pentane has greater mass, stronger intermolecular forces. We don't know, do you refer which one has stronger intermolecular forces? So that's why I say every time, thus pentane will have stronger intermolecular forces. You can leave out than butane. You can leave that out. If you mention the one has stronger, then it is implying than the other. Okay, right. Next one they ask. Methyl propane is an isomer of butane. Explain why its boiling point is lower than that of butane despite having the same molecular mass. Okay, you can see it counts 2 marks. Now, they last year they swapped examiners, or they changed examiners. So previously I could have said, if it's 2 marks, then they'll give a mark for that and for that. But now the new examiners, they always change the way they mark things. Okay, so even those 2 marks, you're going to mention your 4 bullet points. Because maybe they give marks for bullet point 1 and 3, or this year they give marks for bullet point 1 and 2, or whatever. Okay, so you stick with your 4, then you know you get your marks. Okay, so we always start with the obvious difference. What's the obvious difference between 2-methyl propane and butane? The one is branched and the other one is a straight chain. Okay, right? So you're going to say butane is a straight chain whereas one word, 2 words. Whereas methyl propane is branched. You're going to search. I think it's 1 word. Okay. Right, so you're stating the obvious difference. Then you must refer to the strength of the intermolecular forces. Which one thus has stronger intermolecular forces? Butane. Thus, butane has stronger intermolecular forces. Really? Thus, butane has stronger intermolecular forces. Third bullet point is energy. Thus, butane needs more energy and then lastly, thus butane has higher Okay. Question C. They ask, why is it important when comparing boiling points of butane and propane that the compounds have similar or identical molar mass? Why is it important? Say again? They're asking, if we compare methyl propane to butane, why is it important that they have the same molar mass? No, but why is it important? If we want to see who is the fastest boy in school, can we compare a grade 12 boy with a grade 8 boy? No, it's unfair. Okay, we must keep all grade 12 boys. No grade 8 boys. We must keep some things constant. If we want to compare things with one another, it must be fair. Say again? Number? Yeah, so they're basically asking why must the molecular formula be the same, or why must the molar mass be the same? For it to be a fair comparison, there can't be more than one variable. What is the variable that we're testing here? We're testing to see straight chain versus branched. Okay, so what do we keep constant here? We keep constant the mass, we keep constant an ain and an ain. Okay, so the reason, if you compare something with one another, is there cannot be more than one independent cannot be more than one independent variable. You can go on, then you can say it must be a fair comparison, two S's, one S, comparison, something like that. They like to ask a question like this, like, can you remember dependent, independent, constant? I know. Then, which compound in the table above has the highest vapor pressure? Vapor pressure you get if the intermolecular forces can break easily and they evaporate. So which one will have the highest vapor pressure? The one with the weakest intermolecular forces, because it evaporates faster. Which one has the weakest intermolecular forces? Propane, because it has the lowest boiling point. It has the lowest boiling point, it has the highest vapor pressure because it evaporates faster. Okay.
The one with 3 carbons has the higher vapor pressure.
Higher? Yes. So I'll write down the reason here. The reason is propane, which is the shortest, have the weakest intermolecular forces, thus least energy needed to overcome Okay, so propane, because it's the shortest, have the weakest intermolecular forces, thus it needs the least amount of energy to overcome the intermolecular forces. And with vapor pressure, the last bullet point always changes. Thus, it evaporates faster at the same temperature. Thus, vapor pressure is highest. What did I leave out? Molecules. Between molecules. All right. Do you have that exam paper with you? The one that I handed out. handed out yesterday.
Yes. No, you won't finish it.
Dames en heren leerders, want die onderwijzers net reël dat daar 'n omsetskrywer in die afrolkamer afgehaal word vir die hoeveelheid leerders wat voor u sit.
Die is laat.
'n Omsetskrywer moet afgehaal word by die afrolkamer vir die hoeveelheid kinders wat voor u sit.
Alright, so the letter's just going to say that the school ends tomorrow at 1. That's basically what it's going to say because people are going to go play rugby and athletics and netball and blah 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 blah. Alright, say again. Alright, so I want you to quickly open please on page 22 at the questions, page 22 at the top is the okay. So they ask you there, I want to go to question 14. So question 14 on page 22 in your exam booklet. Yes. Okay. So as question 14 says, 3 compounds are used to investigate one of the factors that influence boiling point. The results obtained are shown below. Okay, now we have A, B, C. You see we have butane, we have propan-1-ol, and we have ethanoic acid. Okay, immediately you write there for yourself, what is the molecular formula? Butane belongs to the alkanes, right? And it will be C4H10, I think. Propan-1-ol. It is the alcohols. Propan is C3H. I think it's going to be H10, H8. Help me go. Is it 8? H8O. Is ek reg? 1, 2, 3, 4, 5, 6, 7, 8. Ja. And then ethanoic acid is the carboxylic acids. Eth is 2, C2. Let's quickly check. Ethanoic acid. There's 4 H's and then 2 O's. Now you're like, wait a minute. Different homology series, different masses. How is this a fair comparison? Because we change the functional group, we change the number of carbons. Okay. Then they say there on the right hand side. Can you see the molar masses is 58, 60, 60. Okay. And that there shows you that it is a relative fair comparison. Even though a lot of things change, it's a relative fair comparison because the masses are very close to one another. They are more or less the same, the masses. So that is why it is a fair comparison. Okay, the reason why I asked this question is because a lot of learners got this wrong. That's why I want to look at this. Okay. And they also give us the boiling points. This is negative 0.5, this is 98, and this is 118. What's wrong? Propan-1-ol. Look there in your notes, it's written there in the question. Okay. Something I want you to add to this. Sorry. What type of intermolecular forces do you find with the alkanes? London forces. So you write that for yourself. With the alcohols, you have hydrogen bonding, but you say you have one site, one place, one spot for hydrogen bonding to occur. Thank you, Kananelo. Nee man. I know, but parents want it. Right. Then carboxylic acid also has hydrogen bonds, but it has two sides. Yes. Thank you. All right. Okay. Now they ask at the first question, in one investigation, carboxylic acid. No, I'm just abbreviating. Okay. Right. They say in one investigation, the boiling point of compound B and C are compared. Okay, so they say we must compare propan-1-ol to ethanoic acid. Okay. Is this a fair comparison? Write down yes or no. Refer to the data in the table and give a reason for your answer. Okay. So we just saw 14.1.1. We say yes, it is a fair comparison. Why? Because their masses are the same. Yes, their molecular mass is the same. Okay, 14.1.2. Write down the independent variable for this investigation. Okay, so just a quick recap. Your dependent is the thing that you measure. And in this case, it will always be the boiling point or the melting point or the vapor pressure or whatever you want to measure. The independent is the thing that you change, the obvious difference. Okay, so the thing that we change when we compare propan-1-ol to ethanoic acid is the homologous series or the strength of the intermolecular force. So you have two answers here. You can either say, when I compare these two, I compare different homologous series to one another, or the strength of the intermolecular force. So here, the thing that we change is the homologous series or the type of intermolecular force. Okay, so there it can also be, sometimes we change the length of the molecule. Sometimes we say side chain or no side chain. All right, then question 14.2 they ask, which one of the compounds, A, B, C, has the highest vapor pressure? Give a reason for your answer. Which one will it be? Butane. Why butane? Yeah. It is there? It has the weakest intermolecular forces. It has a London intermolecular forces. Okay. So you had to say A. It has the weakest intermolecular forces. Now I think they did actually accept it has the lowest boiling point. If I remember correctly now. I think they did accept that. Question 14. Yeah. So it has the lowest boiling point. Okay. 14.3. Refer to intermolecular forces in each compound and fully explain the trend in boiling point as shown in the table. Okay. Now the reason this one counts 5 marks and not 3 or 4 is because they want you to explain each one. So you must explain butane and propanol and ethanoic acid. You can't just compare 2 with one another. You must compare all of them. Alright. Okay, so here you still start with your, you still have your 4 bullet points. The first thing that you compare is the, it's the points. Okay, so let's start with the top. Butane has London intermolecular forces. What was the next one? Which one is it? Butanol. Propanol. Propanol has one site for hydrogen bonding. I'm just abbreviating now because I'm scared the bell is going to catch us. And the ethanoic acid has 2 sites for hydrogen bonding. Okay, so there you explain the obvious difference. Okay, I just want to check that I check all the points. One side, that's 2 sides for hydrogen bonding. Right, then the next one is you must refer to the strength of the intermolecular forces. So you can write this in different ways. Okay, I'll say thus the strength increases from butane to propane to ethanoic acid. Okay, otherwise you have to say this one is stronger than this one is stronger than this one. Okay, so if you say the strength increases, the strength of the intermolecular forces increase from butane to propanol to ethanoic acid. Sorry, something that I forgot to do, or we could have made it easier. Instead of saying butane, propanol, ethanoic acid, you could have just written A, B, C. Strength increases from A to B to C. Sorry. You could have used that as well. Then the third bullet point is always what? Energy. Thus, now you can see I'm going to change my words a bit now because I'm comparing a lot of things. Thus, energy needed or required to overcome intermolecular forces between molecules increases from A to C. And then lastly, thus, I'm abbreviating now to hurry, thus boiling point increases from A to C. Okay, so are you with me? So your 5 marks will actually be for stating the 3 differences, for saying that, and for saying that is your 5 marks. Okay, any questions? Anything I must repeat? Ma'am, can I also say this? Why do you say this? Okay, then 14.4, they ask, let's just get to my question again. Which compound, butane 1-ol or propan 1-ol, so butane 1-ol is not there, has a higher boiling point? If you had a gas propan 1-ol compared to butane 1-ol, which one will have a higher boiling point? So they want to compare propan 1-ol with one that is not here, butane 1-ol. Pro has 3 carbons, but has 4 carbons. So because but has 4 carbons, butane 1-ol, for 1 mark they say give a reason for your answer. It is a longer chain, thus stronger intermolecular forces. Okay, you with me? Good luck, grade 12s.